So let's look at a few examples out of 10.7. So in 10.7, we're dealing with imaginary numbers. And remember, if you watch the video that goes to this section, that imaginary numbers are numbers such as the square root of a negative 1. Because we can't take the square root of negative 1. There is no number such that when we raise it to the second power makes negative 1. And remember, that's what a square root is. If we're looking for the square root of 4, we're asking what number times itself, what number squared makes that? What number times itself makes that? So in this case, 2 squared makes 4. But anytime we square a real number, a positive times a positive makes a positive. A negative times a negative makes a positive. So when we square numbers, we always get a positive, which means that there is no number that when we square it makes a negative. So in terms of real numbers, there is no um, solution to the square root of a negative. And we talked about that um, when we were doing square roots earlier in chapter 10. But sometimes we need to simplify negative square roots. There are uses for them, and there are times that they actually do turn into solutions. So we consider the square root of negative 1 to be I. That's the most simple square root of a negative. So by definition, this is just a defining. So if we want to do the square root of negative 25, that's not a real solution because we can't take the square root of a negative. So I'll show the steps to begin with, and then I'll show you all we really need to do. Negative 25 can be written as negative 1 times positive 25. If we have a product, we can take the square root of each piece. The square root of negative 1 is I, and the square root of 25 is 5. So that simplifies to 5 times I. But all that you really have to do, this is the formal way of doing it. All you really have to do is say that since we're taking the square root of a negative, that's imaginary, and then how does the square root of 25 simplify? Well, the square root of 25 is 5 times the I that's already out front. So if we have something like the square root of negative 7, that's imaginary because we can't take the square root of a negative, so put an I out front. But the 7 doesn't simplify, so that's as far as we can go with one like that. If we want to simplify the square root of negative 12, that's imaginary, so put an I in the front. 12 is not a perfect square, but we could call 12 4 times 3. And take the square root of 4, that makes 2. 3 is not a perfect square, so it stays underneath it. So we have an I out front and a 2, so we'll put a 2I out front, and we're left with a 3 underneath the square root. So we can deal with several of those. It's just, if it's the square root of a negative, that's going to be imaginary, so put your I out front and then go from there. Now, one like this is a little tricky because some of us may look at this and say, well, I can multiply negative 4 times negative 9, and that's 36, and that is true, but it turns out if we work it that way, we end up getting the wrong sign for our answer. So we need to simplify each radical separately first, since they're imaginary. In different number systems, sometimes the properties from one number system works for another number system, but that's not always the case. So here, since our square root is negative, that these are imaginary numbers, so the square root of a negative of this is I, the square root of 4 is 2. For the second one, this is the square root of a negative, so that's imaginary, and the square root of 9 is 3. If we multiply these together, 2 times I times 3 times I, we can multiply the 2 times 3 and the I times I. But what is I squared? If I is the square root of negative 1, then to get what I squared is, we would square that. but if we square the left, we have to square the right. So I squared is equal to -1. So in place of I squared, we put a -1. 6 times -1 is -6. So -6 is how we get that. We just have to be careful, make sure we simplify it in terms of I before we multiply anything together. So if you watch the video, then you may have seen that when we have a number of the format a plus bi, this is referred to as complex form. A is the real number part, bi is your imaginary part. So in the previous solutions, all of our answers were either a real number, positive or negative, or an imaginary number, 3i, 5i, things like that. But sometimes we get an answer that has both a real and an imaginary part to it. So let's look at adding or subtracting complex numbers. And the way we add them and subtract them is like we would add anything else. We only can add things that are alike, that are in the same type of family. So 5 and 3 are real numbers, so we add those together. 4i and 2i are imaginary numbers. Even though I is not a variable, we add it together just like you would add 4x and 2x. Our letter is to the first power, so to see how many of those we have, we combine the coefficients, but we don't change any exponents because we're not multiplying. Remember, exponents are for multiplication. So we're adding 4i and 2i. So if we want to know how many i's we have, 4 plus 2 is 6 of those. And that's all we have to do. If we have 2 minus 4i minus 3 plus 7i, a negative in front of this parenthesis distributes. So we write 2 minus 4i minus 3 minus 7i, and then combine like terms. 2 minus 3 is -1. Minus 4i minus 7i are like terms. So to see how many i's, we do -4 minus 7. So the same signs, we add the numbers, take the sign of the bigger. So that's adding or subtracting complex numbers. We can also multiply complex numbers. We multiply like we would multiply with real numbers. If we have something in front, we distribute. We do 2i times each of those. 2i times 3 and 2i times 4i. So 2 times I times 3, we can multiply 2 times 3 and get 6. And then for the over here, 2 times I times 4 times I, we can do 2 times 4 is 8, and I times I is I squared. Just a quick reminder, multiplication is commutative. So if we have 4 things multiplied together, we can change the order, put things that are alike together and multiply those, and so forth. A moment ago, we demonstrated what I squared is. I squared is equivalent to -1. So this term is really a +8 times a -1. So if we finish simplifying, we have a 6i that's positive, and 8 times -1 is -8. And if you're asking why did I swap the order, just because our complex form is a plus bi, the real number then the imaginary number. If you write 6i minus 8 on the test, I'm going to give you credit for that. There's nothing wrong with that. This is just standard form. If we have 2 minus I times 3 plus I, we basically FOIL that out, distribute 2 times each of these. So 2 times 3 is 6. 2 times I is 2I. Minus I times 3 A negative times a positive is negative. I times 3, or we could call that 3i. And then negative times positive is negative. I times I is I to the second. So we have a 6. 2i minus 3i are like terms. 2 minus 3 is negative 1i minus I squared, which we have a minus here from where we distributed, and then I squared itself is negative. Minus a negative makes a positive. So if we combine what's alike, we have a 6 plus 1 that are both real numbers, and then we have minus 1i, or just minus I. Let's do one more of these. Let's have 2 plus 4i squared. So when we square a binomial, we can't just square each part. We have to write the binomial twice and multiply it out. So 2 times 2 is 4. 2 times 4i. 2 times 4 is 8 times I. When we distribute on the inside, 4i times 2. 4 times 2 is 8i. And 4i times 4i. 4 times 4 is 16. And I times I is I squared. So we have a 4 out front. I squared, we said, is negative 1. So this is 16 times negative 1. So we're subtracting 16 from 4. And then we have an 8i and another 8i. 8 plus 8 is 16. So 4 minus 16 is negative 12. And we finished it. So we want to get down to the part where we have a real number and an imaginary number.